Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today's video presentation is about instruction set of 8051 microcontroller. So this video is a part of series microprocessor and microcontroller. So coming to the overview of today's presentation. So how instructions are written in 8051 and what are the transfer instructions, data transfer instructions, exactly as how to copy the data, how to push the data into the stack, how to pop up the data from the stack, and how to exchange the data from one location to the other registers or other memory locations. So coming to the instruction format of 8051 microcontroller. So the general format of an instruction, how we can write the instruction in 8051 microcontroller is, first we need to write the opcode like mnemonic or the code which that operation should be performed, and the next one is destination comma source operand. So this one is destination operand and this one is source operand. So basically there are two operands. You can write one or two operands, or some instructions have only opcode itself also. So here in destination operand, the output will always stored in the destination operand. Most of the cases we will be taking the accumulator A register as the destination operand here. Data can be stored in these two operands, or memory can be there in these two operands. So coming to the instructions. So how many type of instructions we can write using 8051 microcontroller. So basically we can many instructions are there in 8051 microcontroller, but the instructions are specified based on their length. So here by taking one or more operands. So here let's consider this example. So in this particular example there are two operands. The first one is the destination operand and the second one is the source operand. Here the data that is present in register R1 will be copied to the register A. So here as you all know that the microcontroller is having two general purpose register, A register, B register, and R0 to R7 registers will be there, and these R0 to R7 registers are there in 4 banks, bank 0 to bank 3. You can choose the bank before using the registers in that particular bank. So here the data present in R1, which is a register, can be copied to the accumulator. So here in this particular instruction, the two operands which we are using are registers. So you can say that it is a register addressing mode. So if you want to know the addressing modes, please do watch the before video, addressing modes of 8051 microcontroller. So coming to the next instruction, here we have been using this hash symbol, which we are saying that it is a raw data. So it is a immediate data. So we are directly giving the data. So this data will be copied to the 30H memory location. Here we are giving the address. So memory location. So out of these memory locations, the data will be moved to this particular memory location. So instead you can say that 55H is stored in 30H or copied to 30H memory location. Now next one is move dptr comma hash 1234H. As you all know that here the data pointer is of a 16-bit register. That's why here 16-bit data been using to copy to the dptr. If we are using only memory location which can hold only 8 bits, but if we are writing like 1234H, then no. So because the two operands should be matched in the size. So their size should be also matched. Here dptr is a 16-bit register. That's why I've been using 16-bit immediate data. So this 16-bit immediate data can be moved to the dptr. If you want to use dptr as a higher or lower, like if you want to use dptr as 8-bit register, you can use dpl. Or you can use dph, which dpl is the lower byte of dptr, h is the higher byte of dptr. So coming to the instruction formats of 8051. So here there are three types of instructions based on their length. Here the first one is 1 byte instruction. So in such type of 1 byte instructions, only opcode will be present in the instruction itself. So you can say that only mnemonic will be there in the instruction. Like some of the examples of these particular 1 byte instructions are CLR, which is clear instruction. So it will clear the data which this instruction follows. And next one is no operation instruction. Cycles will be moved, but operation wouldn't be do. So ideal controller will be in the ideal condition at this particular instruction. So these are the examples of 1 byte instruction where only mnemonics will be present. So coming to the next one, there will be 2 byte instructions. Here the first byte will be the opcode, which is always the mnemonic, and the second byte will be of either immediate data or direct address. So here are one such examples of 2 byte instructions. Here move, this is the opcode which is byte 1, and here move, here also the move. So these two are the mnemonics which can occupy 1 byte of data. But coming to the next one, here a hash. So here this will consider, so 25H is 8-bit data, so it will consider 1 byte. So byte 2 will be this one, and here 30H is the direct address. As before I have already explained that direct address. So here in this direct address also, the registers which we are using can hold only 8-bit of data. So these occupy the second byte. So these such type of instructions are considered as an 2 byte instructions. And coming to that another instruction which is nothing but 3 byte instructions, which will generally use 2 byte instructions in 8051 microcontroller, but we can use 3 byte instructions also, depends upon the program itself. So here coming to the 3 byte instructions, the first byte always will be the opcode or the mnemonic, and the second 2 and 3 bytes will always be the 16-bit external memory address. So actually we can access 64 KB of external memory using 8051 microcontroller. So to address such type of memory, we should give the 16-bit address locations. So in such type of programs or where we are accessing the data from externally, such type of programs we can use this 3 byte instruction format. Or large constants, like to load the data into the DPTR, as DPTR is a 16-bit register, so we need to load 16-bit data. So this 16-bit data which we are using that particular instruction can hold by using 2 bytes of memory. So that's why this comes under the 3 bytes instructions. So coming to this, here an example I have already given, that is the L jump. So it is long jump. So the long jump, here what we are specifying means it is a long jump. You need to move to this particular address location where it is 300H. Okay. So in such type of examples, we can consider as a 3 byte instructions. Now coming to the instruction set of 8051 microcontroller. So here, what are the instructions? So 8051 is an assembly language programming. So we can write the program to use this controller to perform some other operations. So to write the program, we need to have one set of rules and regulations, which is also known as the instruction set. So by using this instruction set, we can write the programs in 8051 microcontroller. So based upon their operations they perform, I've been categorized this instruction set into 5 instruction sets. So the 5 types. The first one is data transfer instructions. This instruction set is used to transfer the data from registers or memory or external memory or internal memory. And in this particular instructions, there is 2 other specific instructions which are push and pop instructions, which will be regularly used in 8051 microcontroller, and exchange instruction also there. So coming to the second type of instructions, these are the arithmetic instructions. To perform any arithmetical operations, we will be using these arithmetic instructions. So in this arithmetic instructions, addition, subtraction, multiplication, division. Apart from this, we can use it for increment operation, decrement operation. So like that. So coming to the logical instructions, this type of instructions will perform the logical operations, AND operation, OR operation, or logical XOR operation. Apart from this, there are more operations like rotate left, rotate through carry. So such type of operations will come under these logical instructions. Next, coming to the Boolean or bit manipulation instructions. So to clear the bit or to set the bit, to manipulate bits of each bit, one single bit, you can use this manipulation instructions, bit manipulation instructions. Coming to the program branching instructions. So branching is nothing but there is a jump instruction, jump instruction, or rotate, like such type of instructions will comes under this branching instructions. So coming to the here in this particular video, I'll be dealing with the data transfer instructions. Coming to the data transfer instructions, these are the mostly useful instructions in the whole 8051 microcontroller. These are the data transfer instructions. In this first one, the mnemonic. Here move is a mnemonic and a accumulator, and we can use this particular instruction by using direct data. So you can move direct data to the register. So one of the example is move A. So here 25H is the immediate data. That immediate data will be moved into the A register. Here you can say that if you can say that after execution this particular instruction, the accumulator is loaded with A equals to 25. These are the output will be in the accumulator register. So coming to the next type of instruction, it is move A comma Rn. Here Rn is nothing but n is from 0 to 7. As I already told you that in microcontroller 8051, there are 7 registers R0 to R7. Depends upon the bank you have been selecting. Here the data can be moved from registers to accumulator A register. Here the data is present in the register. So one of the example is move A comma R1. Suppose you can write if the register R1 is having any data like 40H, then after performing this instruction, the accumulator A is having 40H. So as well as R is having 40H. So in this particular instruction, move instruction, the data is copied from the destination, source register to the destination register, like source operand to the destination operand. So and the next one is move A comma direct. Here the direct specifies the memory location. You can give memory location of any memory used in the RAM itself. So here the data present in the mentioned. So here what they have mentioned 30H. So the data present in 30H. Suppose if the data present in 30H is 15. So that particular 15 will be moved or copied to A register. So coming to the next one, here move A comma @RI. Here I specifies that it is an indirect register addressing mode. In this particular indirect register addressing mode, only R0 and R1 registers will be used, not other registers. So R0 and R1 register, these two registers will be used to manipulate the data. Here specifies that we are mentioning the data indirectly. So the data present in RI is the address of one particular location. Suppose if the data present in RI is 40H. Suppose consider the data present in RI is 40H. Now what we are saying, this particular instruction saying that go to the data present in 40H location. So if the 40H is location is having another like 21H. So what they are saying, so you need to copy this 21H into the accumulator register. So this is the indirect representation where indirectly we have been mentioning the memory itself. So coming to the next one, move Rn comma hash data. So the immediate data can be moved to the or copied to any register R0 to R7. Why here? Why we are using Rn? Why in this previous one? Why we are not using Rn registers? Only Ri registers we've been using. As in the indirect register, indirect addressing mode, indirect register addressing mode, only two registers R0 and R1 will be used. That's why here Ri specifies only 0 and 1. We're coming to the Rn, n specifies 0 to 7. You can use any one of the register in this 8 register set. So coming to the next one, the direct data can be moved to the or copied to the registers, and the data present in the accumulator can be moved to the direct address. Okay, here the address. Suppose in this particular instruction, if A register is having any 4 data. So in this particular instruction, if A is having 40H, so this particular data will be moved to the direct address location specified as 20H. So this 40H will be copied to this particular address location. So coming to the next one, so as like we are using A register, we can use RN register also. So R0 to R7 registers can be used in this particular instruction. So coming to the other one, here we are using indirect instruction also. The data present in indirectly specified memory location can be moved to the directly specified memory location. So coming to the next instruction set, here we've been seeing that another set of instructions. So here the data is also the same, move instruction. So direct data can be implemented into the address location. Here the data present in accumulator can be copied into the indirectly specified memory location. The data present in the direct memory location can be moved to the indirectly specified memory location. Here the data directly can be moved into the indirectly specified register memory location. And here we are using DPTR, as DPTR is a 16-bit data. So here specifically we've been mentioning that it is a 16-bit data. So 16-bit data will be moved to the DPTR. Coming to the next one, here always we've been using, before this instruction we've been using move instructions like MOV. But here in this particular thing we've been using move C. So why this C? C represents the code byte. So here we are writing the instruction itself in the code. So here move C using this one. So how we will calculate the address of this one? So at the rate A, if the A is holding 10 address, if the DPTR is holding 1345, now what will be the data that we need to take it from the addressing mode? So address. So these two things will be added, and the actual data which we need to copy is in the address location 1355H. So as it is an external memory, because we've been using 16-bit means it is fetching the data from the outside external memory, not internal memory. To access the internal memory, we can use only 8-bit of address. So here 16-bit address is there because it is an external memory. That's why here we are using code byte also, move C. So the same will be, this is PC means program counter, the data address, the program's starting address, and these all. So move C is used for the code byte. Here move X. X means also the external RAM. We've been specifying that we are taking or we are sending the data from the external RAM locations. So here code means external ROM. Here RAM data is specified in the external RAM. So coming to the other set of instructions, in this data transfer instructions, push and pop instructions are there. So what is the use of push instruction? Here see push 30H. So actually the 30H is the address location. So if it is having any data in this one, we are pushing 30H address location into the stack. The data present in this particular 15H will be moved to the stack register. So we are been specifying the register to store this stack register to store this data present in 30H direct address location. So pop instruction is used to get the data already present in that stack register into, so here they have mentioned 40H. So in this particular 40H, whatever the data present in that particular stack will be popped into this 40H. Suppose after performing the push instruction, if the stack register is holding 15 data. So now we are writing pop instruction. So this 15 will be stored in 40H. So this is how pop and push operations will be worked in 8051 microcontroller. Coming to the other set of instructions, those are exchange instruction. XCH will be used for the exchange instruction. So the data completely present in the source register will be moved to the accumulator, and the data present in accumulator will be moved to the A register. It is not copying operation, it's exchange. The total data present in source register will be moved to the destination register, and the data present in destination will be moved to the source register. So this is how exchange operation will work. In this particular thing, you can use register to general purpose register, or you can use two registers, or you can use direct addressing to the register, or you can use indirect address to the register. Here another one is there, like exchange D. Here exchange lower nibble of A with indirect RAM. Here this is the indirect RAM. D specifies like it is a lower nibble. So only apart in this particular A, only lower nibble will be exchanged with the indirect specified addressing mode. So until now we have discussed how we can write the instructions in 8051 based on the instructions length, how these instructions has been categorized, and how many types of instructions are there in 8051 microcontroller. Along with that, we have seen the data transfer instructions in 8051 microcontroller. Thank you.